questions about that? Other than what's the answer?
How did we grade those samples?
Huh?
4 samples.
Yeah.
How did we grade that?
Oh,
That's training data.
yeah. So I just generated a pseudo count for everything, right? So P of x1 equals 1 given y equals 1, right? So I only had these two, so I had to consider adding one for a negative and one for a positive, right? So instead of 2 examples, the denominator now became 4 because I observed 2 plus the vocabulary is 2, and then I add 1 to one side, and right. Does anyone follow? Am I totally? No, you're not. Okay, that's cool. So let's just take the x1 case, right? So P of x1 given y equals 1, right? So my likelihood was if y equals 1, x1 equals 1. Equals the sum of the times it's x1, which is 0, over the number of times x1 equals 1, which is 2, right? So if I'm going to Laplacian smooth, do Laplacian smoothing, I essentially say I want to put a pseudo count on the x1, so it's 0 plus 1, over 2 plus the vocabulary, which is 2, right? So another way to think of this is I can create 2 new examples for the y equals 1. Just put a 1 in all the spots so that I at least get a count, right? So it's effectively the same thing. Because now I always have 4 examples, right? And I always have this 1 sitting there, and in the other case, when I want to do P of x1 equals 0, given y equals 1, then I need this 0 is 1. Yeah, all the math you can always reduce to adding fake examples. Which actually makes a lot of sense. Once you get to SVM, you realize there's a primal and a dual, and effectively that's what you're doing. Is you're saying that I have this weight space, but I can also just imitate the weight space by creating hallucinating examples.
Kevin?
Yeah.
So these values are like products of P of xi given y, right? But
Yeah.
there's also the other terms, the P of y and P of x, but they're like
Yeah, there's a 1/2 here for the P
yeah.
of 1/2 for the P of y.
Yeah,
Did I say it was fair? I don't even remember. It's really irrelevant because.
Yeah, or fair is not.
So when did I say that P of y equals anything at any point, or did I just?
No, there's never given.
Okay, we'll take the maximum entropy assumption. It's this 1/2. Doesn't really matter. Okay. Any questions about this? Other than what this table says here. I don't know what these answers are, but you can figure them out. Somebody, I should maybe put a bounty on them. First person to solve it correctly gets the
A.
What? An A? That's a strong bounty. Okay. I'll skip EM until the end because although I'm running some time. But. Okay. Linear regression. Let's do that one. Let me erase some of the board. All right, so linear regression. So we have a single variable regression here, where my x is just drawn from single variate, or just univariate, and I have my normal output space. So one feature linear regression model, y equals ax plus epsilon, where epsilon is my normally zero mean normally distributed. Nothing fancy. Accordingly, this is my f of x in here, and this is me writing it out. Hopefully I keep it on the page.
Oh, no.
Yeah, where you are.
Oh,
Yeah, I looked
Oh,
for
that
this.
was from a
that was
book
from the
that-
labels are missing, the data's missing.
Oh.
But yeah, so y is not observed.
Oh
Oh
no.
no! Alright. Assume you're given m examples and sigma is known, and it doesn't really matter. Write down the maximum likelihood estimate. I hope I actually wrote this down. Obviously, I can produce it. Yeah, it'd be better if I can get them both on the screen, but let's see. No.
You could zoom out a bit.
Ah, good point.
Or not.
Or not. I can't write on the wall. Okay, well, it doesn't matter. Well, I'll just write it and people can back reference it. So it's, I mean, this isn't asking anything to, I mean, I'm just assuming the I and D case, right? So it's a product of I 1 over sigma 2 pi.
And the exponentiation is under the denominator for the outside.
It's here, right? This is just the, this is right. This is
Yeah,
totally
that's
right. Yeah. And since I wrote that now, it looks like that. Let's see, there's a space.
And can you turn off the lighting?
Yeah.
It's really hard to see.
Oh, just mute this, you mean? That?
Oh, oh yeah, yeah, okay, that's good.
Is it really that much brighter?
Can't see that here.
Well, I mean, there's a light shining.
Yeah, there's
Glare.
glare. Depending
Oh,
on
the
where you
glare.
are, there's
I see.
glare right there.
Okay. Yeah, I mean, it's just the product of this. I mean, all I'm doing is I'm saying that this is my likelihood of the case. This is my likelihood of that many, of all my examples, put a product together. Okay, so this is, yeah, I mean, it's, well, I'll just put it here. Argmax, A and R equals A, right? So B is, if you fiddle around with this, and you don't even need to fiddle around with it if you take the, you could take the maximum likelihood estimate directly, because when you take the log, this ends up becoming a constant, and when you differentiate it drops out. But for simplicity's sake, what I put in here is that we'll just start with the form that this equals argmax 1/2. So I already assumed that I took the log and everything for you. I squared. So took the log, got rid of things that only had constants, blah, blah, blah. This is just directly in D. So starting with this form, derive the closed form to solve A in terms of xi and yi. So if I say that, well, yeah, I'm going to call this here.
Can I ask why it says argmin versus argmax?
Oh, sorry, you're right. It should be argument. Because I took the negative log likelihood, so that I just turned it into a set problem. So when I simplified it, I just made it easier by making them in, because it should have been a negative max. if you want, actually take this product and go ahead and take the log and figure out how I got here. Useful. Okay, so if I call this FA, so I want to do dFAX over dA. No, sorry.
Is it AX or A minus X?
A comma X. Actually, I don't like my notation. Let me just do this instead. I think that'll just make it more confusing. I'll just drop all this and take the derivative directly. So d over dA of 1/2.
Which part are you doing right now?
I'm just doing the maximum likelihood estimate. Right. So if I take this derivative, and so this is why I called it, and I'm going to set this equal to 0, right, and solve. So this will be equal to some I yi minus axi negative xi. And then I'm just taking the negative. So this is, all of a sudden,
Just look at the 1/2. No,
the 1/2's fine because I got the squared to take it away. So y, and then this is negative x, this is right.
It comes out.
Could you step to the side just for a second? Sorry, thank you. Appreciate it. Got it.
So yeah, so let's just multiply it out for a second. Minus xi yi. Yeah, okay, that's fine. So in that case, if I solve for, I want to get the a alone, right? So if I was to solve for 0, a equals sum over I xi yi over sum over I xi squared. Any objections?
Kevin, would this be the same as gradient descent because it's just one variable? Because it's just a, right?
So there's not, so it's not gradient descent in the sense that this is a closed form.
yeah.
But right. But at the same time, it's the same thing because I'm doing a single coordinate descent directly to the solution. I don't know the step size. I see all the data here, so it's definitely not stochastic gradient descent. Yeah, it's a close call. Single variable. I think it's the same thing, frankly. Good point. I didn't catch that. I was just going for simple equation, but yeah, that's yeah. Okay, so then I state, which is overkill, and I maybe should just skip given how much time we have. So I think I will actually, to be honest. I'll put the solution out, but so if we put a normal prior, actually, I'm going to put this up anyway, if you want.